Alright guys, so welcome back. So in this video we're going to talk about sorting. And the idea of sorting is to put an array or an array list in some kind of order. And that could be a numerical order, of the alphabetical order, and that kind of thing. There are several different ways to do this. This is actually a very important topic in computer science studies. And we're going to talk about three today. And again, the whole point of these is to take a list and put it in some kind of order. All right, so the first thing we're going to talk about is selection sort. And what I want to do is I want to talk about how the algorithm works. And what an algorithm is it's just a strategy for how to do something. So an algorithm is a strategy to attack a problem. So all of these different sorting algorithms have the same goal, to sort a list and put in order, but we're just going to talk about a couple different strategies and ways you can do so. Okay, so here's the idea behind selection sort. Selection sort basically says you're going to go through the list, and then you're going to select the smallest element. And that's something you guys have done a ton of times. You've gone through a loop, find the smallest, or go through a loop, find the biggest. And then you do something with that at the end. You return it, you print it, whatever. Okay, you're going to go through the list and select the smallest element. And then, after you have picked the smallest element, then in that case what I'll do is I'm going to move that to the back of a second list. And then after I've moved it to the back of that second list, then I'm just going to go ahead and repeat this process until my first list is empty. Okay, so I wanted to visually demonstrate this for you guys. So here's my original list. And what I'm going to do is I'm going to now create a second list that is a sorted version. Okay, and my goal is to take these and put them in order. So this is my original list. So what I'm going to do is I'm going to loop through and store the minimum. Okay, so I'm going to keep track of what the minimum is. So my minimum, let's see, is 5. Nope, my minimum is 5. Okay, now my minimum is 4. Now my minimum is 3. Now my minimum is 2. Okay, so now that I've gone through the whole list, now I'm going to take this min, and I'm going to take it out and put it on the end of my sorted list. And now I'm just going to repeat this again. So I'm going to go back to the beginning and I'm going to reselect my smallest. Okay, now the smallest is 5. Nope, smallest is 4. Now smallest is 3. Okay, so now I'm going to take that out and I'm going to put it at the end of this list. Okay, and now I'll do it again. So which one's the smallest? 5. Okay, nope, now 4 is smallest. Okay, so now I'm going to take 4 and put that on the end there. Okay, so now I'll go through, figure out which one's the smallest. 5 is smallest. Okay, so now I'll put 5 out. All right, and now I'm down to a list that only has one element in it. So I just have one element. So I'll take that out and then just throw it on the end of the sorted version. So that's what the process looks like. And that's kind of my idea for how I'm approaching this. So in terms of code, and I'm not going to give you the code obviously because that's your set of labs, but the coding strategy for this is basically, okay, so I'm going to set up my min variable or variables depending on it, and then I'm going to loop through the original list to find the smallest element. And then once I've found the smallest element, after I've looped through the whole thing, so this is obviously like a for loop, and then after I've gone through that whole loop, then I'll take the smallest element out of the original list and then add it to the end of the new list. And then what I'm going to do from here is I'll just go ahead and just repeat this whole thing n times. So however many elements are in the list, if I have 5 elements, I need to find them in, take it out, add it at 5 different times. Okay, so that's the strategy behind selection sort. Okay, now we're going to talk next about something called insertion sort, which is again just another way to put a list in order. So the general idea behind insertion sort is we're just going to take out one element at a time and insert it into the correct spot into a second sorted list. So again, we have a second list that we're going to have. Let's go ahead and call this will be our sorted list. So what I'm basically doing is I'm going to say, okay, here's the 5. So first off, the sorted list is empty, so I'm just going to tack that on first. So now once I've done that, and now I'm going to go through, I'm going to make this, this will be more interesting. Once I've done this, I'll just go ahead and go through and say, okay, my next element's an 8. Where does an 8 go? Does an 8 come before a 5? No. So I'm going to take the 8. Does it come? Okay, well now I'm at the end of the list, so now I'm going to take it and add it here. Okay, so now I'm going to go to here. How about a 4? Does a 4 come before a 5? Yes. So what I'm going to do is I'm going to add it here. So I'm going to insert in this spot. As you guys may know, the add that's in Java automatically shifts everything else down. If you add something to spot 0 or spot 1, it shifts everything behind it down a spot. So now I get to this spot and I say, okay, where does the 2 go? Well, 2 comes before 4. All right, so I'll put the 2 in there, so 2 goes first. All right, and again, that's going to shift everything else down. So now I'll get to this list and I'll get to this 3. And then I'll get to the spot, okay, where does 3 go? Does it come before 2? No. Does it come before 4? Yes. So what I'll do is I'll go ahead and I'm going to insert it into that spot right here, and then everything else is going to get shifted down like this. Okay, so one by one, again, I'm just taking one element at a time out of the original list and inserting it into the correct spot. Now let's do this again. Let's make one more. So let's say we have, I don't know, an 11 here. Let's look at what this process is going to look like. So if you have an 11 or a 12 here, you say, okay, does 12 come before 2? No. Does 12 come before 3? No. Does it come before 4? No. Does it come before 5? No. Does it come before 8? No. Does it come before... Okay, so if there's nowhere to go, and this is kind of a spot that's tricky, so if there is nowhere to go, make sure you just add it on the end. So the comparison is basically you're saying, like, does this come before each individual element? So I'm not trying to like sandwich, does it come between 2 and 3, between 3 and 4? That's going to give you out of bounds errors. You just want to say, does it come before this? Does it come before this? Does it come before this? Come before this? Come before this? And if it doesn't come before anything, then the answer is you just put it at the end. You don't want to check the other way. You don't want to check if it comes after, because like, does 7 come after 2? Well, yeah, but we don't know how much after, right? So that's the idea. Just try and go through, and I'll go ahead and write out this code as well. So your general thought is you have a for loop. All right, so what you'll do is you'll just pick element I from the original list. And then once you've done that, you'll have another for loop to loop through the sorted list. And then you just say, okay, basically, if it goes in that spot in the sorted list, insert it there. And then obviously you want to just make sure that then you like break out, because you only want to kind of insert it once. That's important. And then if it goes at the end, add it on the end. And then this whole process is going to kind of get repeated. So like the last one, it's just going to have kind of like a nested for loop here. Where you're going to do this just several for each element. But again, that's kind of what we're doing. We're looking at one element at a time and just saying like, okay, I picked element I from the sorted list, and then I just go through the sorted list, and if that being like element I, goes in that spot, put it in there, and then have a case for if it goes at the end. Okay, so that's insertion sort. So you just take one element at a time and insert into the second list, and the second list again is always in order. You're just trying to insert there. Okay, the next thing I want to talk about was merge sort. So merge sort is a little more complicated, but for those of you who love recursion, you'll probably love merge sort. Okay, so here's how merge sort works. Now I'm going to draw pictures because I think trying to illustrate this in Word with typing is going to be complicated. But basically what you're doing is you're going to take a list and you're going to recursively cut it in half until it is all single elements. So that's like your base case. You get down to a length of 1. So I'm going to try and draw this out for you here. So let's say you have this list, which is 4, 8, 7, 2, 6, 1, 3. And again, our goal is to put this in order. So if we recursively cut this in half, we're just going to chop this here into 2 arrays. So I'm going to break it down into 4, 8, 7, 2, and then 6, 1, 3, like 2 separate arrays. And again, I'm going to keep chopping in half. So I'll go down to 4 and 8 and 7 and 2, and then this goes to 6 and then 1 and 3. It doesn't matter if you put the 1 with the first one and the second one. Okay, and then I'm going to break these down further until they're all arrays of single elements. So I have 4 and then 8 and then 7 and then 2 and then the 6 obviously is by itself, and then I have a 1 and a 3. So I'm just breaking it down into a bunch of separate little arrays like that. Okay, so now that it's all single elements, then what I'm going to do is I'm going to try and put it back together. And then what I'll do is I'm going to merge the list together. That's why it's called merge sort. So I'm going to merge the list together by just comparing one element at a time. So by just comparing one element at a time. Okay. So what I mean by that is I'm going to just take like two elements. So say I have, you know, like a 7 and then a 4. I'm going to put those together and say, which one's smaller? 4. Well, 4 is smaller than 7. So I'm going to put the 4 first and the 7 second. And, you know, if it was like 7 and then 10, I put the 7 first and the 10. And I'm just going to do that over and over. So the 4 and the 8 are going to merge back into 4 and 8. The 2 and the 7. Okay, which comes first, 2 or 7? So that's a 2 and then a 7. Okay, and then, you know, we'll put the 6 and the 1 together. The 1 comes first, and then the 3 carries out. You can put the 1 and 3 together, doesn't matter. Okay, so now I'm going to merge these back together. So again, what I'm doing is I just compare the first element of each list. So in this merging process, I compare the first element of each list to see which is the smallest. And then I'm just going to do that repeatedly. So 4, okay, so I'm looking at this, 4 and 2, which comes first? Well, 2 is smaller. Okay, so now I kind of cross off the 2. So now I look at the first element of what's left, 4 and 7. Well, which one's smaller, 4 or 7? Obviously the 4, so I'm going to put the 4 in. Okay, so now I'll cross the 4 out. So now which one's left? Well, I have the 8 and I have the 7. Which one's first? The 7. So I'll put the 7 in. Which one's left? Well, the only one left is the 8. Okay, and now I'll merge these back together. So I merge together the 1 and the 6. Okay, well, the 1 comes back first, and now I compare the 3 and the 6. Well, 3 is smaller, so I'll put the 3 there. And then, of course, like, once the list is empty, then obviously you just take the other one. So you don't have like an out of bounds error there. Okay, so the 3 is gone, so I'll just take the 6. Okay, so now I'll just merge this back together. So again, I'm just looking at the first element. So when I put these back together, I say which one comes first, the 1 or the 2. Well, 1 comes first, obviously. So then I move on to the next one. Which comes first, the 2 or the 3? Well, 2 is smaller than 3. So if you guys see what's happening, I'm going to have one variable to track where I am in this list, one variable to keep track of where I am in the second list, and then another variable to kind of add one at a time into my final sorted list. So I'll now compare the 3 and the 4, okay? And then the 3 goes in. So now I'll compare the 4 and the 6. The 4 comes in. Okay, now I compare the 6 and the 7. The 6 comes in. Now this list, of course, is empty. So I'll just copy over the 7, then copy over the 8. And there, my friends, is the sorted list. So that's how merge sort works. I know this looks a little complicated, but that's the general process. We broke it down into these single elements. And then we brought them back together just a little time. And again, there's nothing more complicated mathematically than like which is bigger, one number or the second number, and just doing that over and over. You know, once you get down to just one list, the 7 and 8, then obviously just take 7, take the 8. So that's merge sort. So that's kind of more recursive, and the insert sort, selection sort are more for loops. So those are some ways to sort lists and sort lists, and those are the ones you need to know for the AP test. But we'll talk about a couple more things in class. All right, bring me some questions. Thanks for watching, and I'll see you guys soon.